All right, we've been working in section 6.2, addition and subtraction of rational numbers, and we're close to the end of it. We've done part of a problem, and I believe we left off with the other version to do. Try to get to it. Martine. Yes. Martine, and we did one version of this. Is that right? We did the one that kept things in mixed number form. Okay. So I'm going to take this same expression, we're going to go to the next slide, and we're going to do it in the improper fraction form. And if you'll remember, neither one's really preferable. They're both going to be kind of ugly on this particular problem. But mixed numbers means that I'm going to actually get them into, improper fractions means I'm actually going to get them into the fact that they have top heavy, right? They're all heavy on top, and there's no whole value piece in front of them. So in each one of them, I'm going to be multiplying the denominator times the number in front and adding, and we're going to do that to all of them. So 4 times 8 is plus 3, 35. So 35 over 4 on the outside, minus. On the inside, 1 times 8, 8 plus 7 is 15, so I have 15 eighths. 2 times 8, 16 plus 3, 19. And then I have 3 times 1 plus 2, 5. So they're all in improper form. There are 2 of them that I can add together right away. That's pretty nice. So I probably want to do that just because they already have a common denominator before I do anything else. Because it would be really nice, and I think it works out on this one, if that addition is able to reduce my denominator so that my denominator gets at least a little bit smaller before I go and make it big. So we're going to try that. So 35 over 4. So what is 15 eighths plus 19 eighths? 34 eighths. And they're both even, right? So since they're both even, I can reduce this. What will they both divide by? 2. So divided by 2, I'll have 17 and 4. Everybody good with that so far? Okay. So that's good because I already have a denominator of 4 in my problem, and I won't have to continue using an 8. So now 2 of my denominators actually will match. So I'm going to go ahead and distribute this negative through because 2 of the denominators match already and try and combine those because I'm able to. So this is 17 over 4, and then I have minus 5/3. Okay, so 35 over 4 minus 17 over 4, what's that going to give me? $18 over 4, yeah. Once again, these are both even, so you could reduce it if you want to. I'm going to leave it this time just because, not because we need to, but just because you're not always going to recognize when to reduce things. So we'll just leave this one this way. If you want to reduce it, go for it. So if we are going through the subtraction definition that we saw last time, we would do 18 times 3 minus 4 times 5 over 4 times 3. So what is 18 times 3? Anybody have a calculator today?
54.
54, thank you. So 54 minus, the next one I know, 20 over 12. What's 54 minus 20? 34. So at this point, I will reduce, and I strongly encourage you to reduce fractions before you change them back into mixed numbers. They're going to be a lot easier to work with that way. So 34 and 12, what do they both divide by? 2. We already did 34 divided by 2 earlier, so that's 17. And I have 6, so 17 and 6. And then how do I change it back into a mixed number? Divide. So I have 17 divided by 6. How many 6s are there in 17? 2. 2 times 6 is 12. I subtract and I get a 5. So my answer from here is the 2 and then the 5/6. That's the numerical part of my answer. I'm going to flip back. We need to have a unit on this answer. What are my units on this problem? It's yards. So I need to make sure I have yards in it. Did I do that last time? I didn't. Let's put it on there in the last one too, yards. We should definitely have units on our answers. Okay, so this one was kind of nice because the denominators ended up sort of matching up in pairs eventually along the way. If they hadn't, it could have gotten much larger, much quicker. Or if I hadn't noticed that at the beginning, right, and made those reductions along the way, they would have been a lot larger. So this is a second option. And again, I don't care which one you use, but I do want you to know how to use both of them, okay? All right, estimation is the last thing in this section. So we're going to be looking at estimation with convenient fractions. Some of the problems in your book will give you sort of almost like a multiple choice kind of thing where it says, choose which one of these is the best choice, right? Sometimes they just give you nothing and they just say, use a convenient fraction. So convenient fractions, generally speaking, are just easier to work with. So these are some examples of convenient fractions. I know 0 and 1 are not convenient fractions. They're whole numbers. I get that. But sometimes a number is small enough that it's really close to 0, right? It's really close to 1. So those are some values that we often estimate with too. So we're going to look at two examples, 12 over 78 and then 2 over 1001. Okay? And we're going to use, I'm going to do it like your book does it. This isn't how I normally do it, but then you guys get to your book questions and you get confused. So I'm going to do it the way that they're doing it. So they give you a list of numbers to choose from. So I'm going to use that as well. So we're going to say our list of numbers to choose from is 0, 1/4, 1/2, 3/4, and 1. That's my arbitrary list of numbers at this point, okay? Which one is it close to? Well, so for A, I have 12 over 78. Well, 12 over, let me actually do this then, given what I know is about to happen. Let's do them in an eighths one in there too. 1/8, and we'll put in here over here 7/8. Okay. Sorry, I'm making up directions on the fly. You'll have directions in the book that are given. That won't happen. All right, so we have 12 over 78. So 12 and 78 do have a 2 in common, and we could reduce it. But that's not really what the question's asking. It's just asking us to give an approximate value. So for example, on this one, the number 12 is really close to what nicer number? What nicer number is there than 12? It's really close to 10. Right? It's close to 10. And 78 is awfully close to 80, yes. 10 over 80 is really nice because I can reduce it nicely. How will 10 over 80 reduce? 1/8. So this is 1/8, which is one of my ones that I put up at the top, right? So 1/8 is a good fraction estimate for this. And then it asks us whether our estimate is high or low. So it doesn't ask us to justify that anywhere in your book. So you can do that in any way that you wish. So I understand that for some of you that just means you're going to put in your calculator and look at some decimals, and that's okay. But I do want to talk to you about how you would justify that from the perspective of fractions. So when we look at these fractions, my numerator, did it get bigger or smaller when I changed it from 12 to 10? It got smaller. So right here, when that happened, I ended up with a smaller number from the top part, my change on the top. Now, but my denominator went from a smaller number to a bigger number. What did my denominator do? Did it get smaller or bigger? It got bigger. Now, that might look like a problem. Part of it got smaller and part of it got bigger, but it's actually really good. When the top gets smaller, the whole fraction gets smaller, right? Right? But when the denominator gets bigger, what happens to the fraction? It also gets smaller, right? If we took the same classroom space, and we're in here, and we added 10 more people to the classroom, the amount of space you have in this classroom decreases when we increase people, right? That's what division does. So the numerator getting smaller made the fraction smaller, and the denominator getting bigger made the fraction smaller. So this estimate is a low estimate. It's smaller than the estimate we started with. So my estimate is actually low. 2/1001. Let's do the same sort of thing. 2 is not a bad number to work with in and of itself, so I'm going to leave it. I didn't mean to put equals, I meant to put approximately. But what number is 1001 close to that's nicer? 1000. And we could reduce these and we would get 1/500. Now that's an approximation, so if it was an open-ended question, that would be perfectly reasonable as an approximation. But looking at my list of numbers at the top that I've added in there, which of those is it closest to? It's 0. This number's tiny, right? 1/500, that's a very small number. So this is best approximated by the number 0. Is 0 a low estimate or a high estimate for 2/1001? Low. It's lower than what I began with. All right, any questions on those?